This is a theorem that you need to know and be able to use on quizzes or exams. The remainder theorem states that if a number c is substituted for x in a polynomial f of x, then the result, f of c, is the remainder that would be obtained if you divided f of x by x minus c. That is, if f of x is x times x minus c times a quotient plus the remainder, then f of c is always equal to the remainder. This would be the part that we need to make sure that we understand. Why? What would happen if I take this equation and I substitute c for x? Well, if I substituted c for x, I would have f of c equals, remember that I'm dividing by x minus c, but if I substitute c for x, I'd have c minus c times whatever the quotient is, plus whatever the remainder is. Well, what happens right here? C minus c is how much? 0. 0 times the quotient plus the remainder is how much? This is 0, and so what I'm left with is just the remainder, basically showing that f of c always equals the remainder when you divide by x minus c. Now, this probably doesn't make a whole lot of sense, so what I'm going to do is show you with an example, and I'm actually going to give you a challenge. Okay, what I'd like you to do is get out your graphing calculator, and I'm going to challenge you to do this on the calculator while I do it using synthetic division and the remainder theorem. All right, basically here what I would like to do is take this function and evaluate f of negative 2, which simply means that I'm going to take this function and everywhere there's an x, you would substitute negative 2. So using your graphing calculator, I would like you to evaluate this function at negative 2. Okay? I'm going to do it using the remainder theorem and synthetic division. So I'm going to say ready, set, and let's go. Answer is negative 6. Now, did you finish before I finished? Generally speaking, I'm able to do synthetic division and the remainder theorem quicker than we can by using a calculator. And the reason being is on your calculator, you're having to type in 2 times negative 2 cubed minus negative 2 squared minus 4 times negative 2 plus 6, and then even though your calculator is doing the work for you, you're having to type in quite a bit, and then you get negative 6 out when you're finished. What I'm doing here is I'm writing a lot down, but my operations are very simple. They're basically multiplication and addition. So multiplication and addition is obviously a little bit more simple than cubing and squaring and multiplying by values. So in general, it sometimes turns out quicker to use the remainder theorem. Now that we've done the challenge, let me erase what we've done here and let me slow down and show you what I've done. So here, what I want to do to use the remainder theorem is I would want to take the value here that I'm wishing to plug into the function, and I will use that value in my box. Then I'm going to take the coefficients off of my function f of x. So I have the 2, there would be an understood negative 1, and the negative 4 and the 6. I'm going to write those values down. Once I've written those values down, draw your line, bring down your 2. Okay, and then from here, multiply your negative 2 by your 2. So that's negative 4. Add these down. That would be negative 5. Multiply the negative 5 by the negative 2 in the box. That would be 10. Add these down. That would be 6. and then multiply the 6 by the negative 2. That would be negative 12, and then add down, and there was negative 6. Anytime you're asked to evaluate a function at a particular value, what I want you to write down when you're done is I want you to write down f of negative 2 equals whatever value you got here, which is negative 6. It is extremely important that you write your answer in this particular format when you're finished.